Hi everyone. Today let us try to solve some problems on Thevenin's theorem, especially on dependent sources. So this is the problem given to us and is asking to try to find out the current across the 10 ohm resistor. So here you want to find the current across 10 ohm resistor using Thevenin's theorem. It's very clear this problem comes under uh, dependent sources and consists of an independent sources. Okay, so independent source is nothing but the voltage source to us. So this is nothing but 10 volts, and this is the one more dependent given dependent source with these polarities which are marked. So this is a little bit very good problem, and it's very simple to solve. So solving these problems will help you to understand the main problems which generally appear in competitive exams and in normal academic or university problems. So these are very important if you analyze these problems. Let us first try to find out the first step. So the first step of solving this is we need to find out the two parameters. First one is we want to find out the open circuit voltage, and then we want to the find out the Thevenin's resistance, and here the load resistance is already mentioned in the problem as so this is the value of RL, that is equal to 10 ohm. So first let's try to solve VOC, and second let's try to find out R Thevenin and what is the amount of current IL flows. So the voltage at this point is VOC. So I'm going to get the value of IL is equal to current is leaving. So it's nothing but VOC minus 0 divided by R Thevenin plus RL. So we need to find out this. So how to find out this? Let us try to do it. So first step is already mentioned. We need to find out open circuit voltage. Okay. So first step is finding out the open circuit voltage. So how to find out open circuit voltage? See here. So how to find open circuit voltage is first remove the load resistor, and if it is removed automatically current will become zero and it will create some voltage to flow. Okay, so for your convenience I am redrawing the network. So this is the network given to us, and this load resistor we have been performed open. When it is open, the current is zero. This will develop a voltage which is called open circuit voltage, and this is called negative terminal. So already in the problem, the current is flowing like this, and this is an 3 into I naught. This is 2 ohm resistor. This is 10 volts. When you see this problem, mm, we need to the voltage at this point and the voltage at this point both are same. Okay, so why? Because it is already open circuited, both are connected to the same point. Okay, so the voltage at this point is also VOC. So coming to this type of source, this is 3 times I naught. So I can call this as a current dependent, current dependent. What kind of source is there? Positive, negative. That's why this is called positive and negative will be there for which sources? Voltage source. So this is called a current dependent voltage source. Now you got the VOC here. So we want to find out the voltage at this node. So how to find out? So already the I naught is marked in the problem. Let us try to mark the current in this branch is flowing like this. Okay, mark that current as some unknown current as some I1. So now in order to find it, so apply nodal analysis at node VOC to find out the value of VOC. So you see here to this node, how many entering currents are there? No entering currents. How many leaving currents are there? Already in the problem, I naught is given and the current I1 is flowing. So I can write down 0 is equal to, so I naught, we have to write down in terms of VOC. Okay, so how to write down I naught? So I naught can be written as VOC minus 0 divided by, so this resistor is 5 ohms, okay, divided by 5 ohms plus, how to write down the current? I1 in this branch. So I want to write down the current in this branch. Current is leaving, okay. So current is leaving. What is the voltage you are going to get? VOC, and it is leaving terminal is minus 3 into I naught, and here it is a minus 10, minus 10 divided by, what is the branch resistance you are going to have? 2 ohms. So now you can see this equation. We require only VOC, but we have a problem of I naught. So we need to express I naught in our required format. Okay. So I naught I have to express in terms of VOC. So check out where I naught and VOC is there. So here I naught is there, here VOC is there. So already we have written I naught is equal to, we can, so how to write down this current I naught? I naught is equal to VOC minus 0 divided by this resistor. So now the problem of I naught is also solved. So let's try to resolve this one. So when you solve it, you are going to get 0 is equal to, I am going to take VOC as common. I am going to get 1 by 5 plus 1 by 2, and next one minus 3 by 2 I naught. This is minus 5, and this will be equal to plus 5. So try to substitute the value 5 is equal to, this will be 0.7, this is minus 3 by 2 into I naught. So I don't want I naught, I want this value, so which is VOC minus 0 by 5. So when you take common from here, you are going to get 5 is equal to VOC into, so the resultant when you perform 0.7 minus 0.3, so you are going to get the VOC is equal to 12.5 volts. So successfully we find the value of VOC. Now coming to the second part, we need to find out the Norton's equivalent. Okay, so how to find out the Norton's equivalent? So second step, so this is the network given to us. We need to find out the Norton's equivalent. Okay, so first remove the load resistor. When you remove this load resistor, you are going to get the network like this. This is a 2 ohm resistor, and this is an current dependent voltage source. This is a 3 into I naught you are going to have, and here you are going to have a 5 ohm resistor and consisting of this source. So this value is 10 volts. This is of 2 ohm. This is an source, and we have to remove the load resistor. When you remove it, then automatically we need to find out RThevenin. Sir, how to handle these sort of problems in finding out RThevenin? So RThevenin can be find out by two methods as already discussed. We have one dependent source and one independent source. When you have one independent and one dependent, then the formula for R internal or the formula for R Thevenin is, so we have to first find out VOC, and you short circuit that branch and find out the current in that branch. So we are going to short circuit it. Okay, so now see here, so we are going to perform short circuit here, and you are going to find out the current ISC. So now I require the value of ISC. So how to solve it? Okay, you see here, this is 3 times I naught. Okay, so here the current in this branch is I naught. So when you perform short circuit, okay, so when you perform short circuit, what will happen is, so we require this ISC. So when you perform short circuit, so the current will come to this branch and current will not flow in this branch. Why? Because current always flow in low resistive path. Current does not flow in high resistive path. Therefore, current will flow only in the short circuit path. It doesn't flow in a 5 ohm resistor. So I can say that here this can be eliminated. So you are going to get, so here you are not going to get any resistor. Okay, so now we are going to find the solution. So we require the current ISC. So how to find the current ISC? The current is flowing like this in this direction as it is shown. So whenever the current is flowing, we have to write down the formula for current. So very simple. So I require ISC. So current is leaving. What is the leaving polarity of the voltage? This is 10 volts. Okay, so this is 10 volts, and here the current is leaving. This is plus 3 into I naught minus 0 divided by the resistance offered. Okay, 2. So already from the problem it is clear that so whenever you have a short circuit, whenever you have an parallel branch with respect to one branch with high resistance, automatically current will flow only in low resistive path. It doesn't flow in high resistive path. Therefore, it's very simple to understand. You have one 5 ohm resistor, you have one short circuit path, R is equal to 0, R is equal to 5 ohm. So the resultant of this is, so generally if you do by layman method also, you'll be getting the same. You can see here. So you are going to get and resistor. So this is nothing but 0. Why? Because 0 is so R resultant is so 5 is there, 1 is there. These are two are connected in parallel. 0 into 5 divided by 0 plus 5. So whenever you have this type of connection, therefore numerator is 0, the resultant is 0. This is like a simple subject to understand shortcut. Or if you are very expert, you see here current will come into this branch. It doesn't flow in this branch. Okay, so the current will try to flow only in low resistive path. Current doesn't flow in high resistive path. Okay, so this is how to understand this concept. For resultant current is 0. So this current you are writing, so this is plus 10 plus 3 I naught, 0 divided by 2 you are getting. So but the confusing thing is so we require I naught, but how much current will flow here in this branch? Zero current. So automatically this term will become 0. Therefore ISC is equal to 10 by 2, which is nothing but 5 amperes. So we are successful in finding out the all the values of VOC and IOC. So we had been got this VOC as 12.5 volts, and we have been obtained this R Thevenin as so this. So you have to get the value of ISC. Okay, ISC is around 5 amperes. So what is the formula of R internal? R internal is equal to R Thevenin is equal to VOC. VOC we have been got 12.5 volts divided by. So ISC is, so formula already we discussed. VOC by ISC is 5. So you are going to get as 2.5 ohms. So come to the starting of the problem. So here this is 2.5 ohms. So resultantly, so substituting the formula, 12.5 divided by R Thevenin is 2.5 plus 10. The resultant current, after doing the calculation, you are going to get it as 2.5 amperes. This is your resultant load current. Hope you are able to understand. If you are unable to understand, I will recall the problem or it is concerned. You see here, this is a problem consisting of independent source and dependent source. So the procedure we'll try to discuss. So now load is removed, automatic the voltage will be available at this point, which is nothing but VOC. So I'm finding this VOC by using a nodal analysis. I'm assuming that the current already in this branch is marked as no entering current is there. Leaving currents are I naught, and the leaving current in this branch is I1. I'm expressing VOC minus 0 by 5, VOC minus 3 I naught minus, sorry, here minus 10 divided by 2. If you solve it, you will get VOC. But unfortunate thing is, so when you are solving this, you have been got the value of I naught. So but I naught is there, which is damaging the problem. So we need to express I naught. So how to write down I naught from this node? So I naught can be written as VOC minus 0 by 5. So we expressed I naught in terms of VOC, and resultantly only one unknown exists. We find it. This is called This is not about the subject. This is about how to solve the problem. This is completely based on maths. So the mathematical way of solving it. So now come to this problem. So you have the next source. So already I told this problem is consisting of independent source and dependent source. Here we need to find out Thevenin's resistance. How to find the Thevenin's resistance is VOC divided by ISC. Already the first step we had find out VOC. Now we have to remove the load resistor and replace the load resistor with an short circuit current. So therefore the short circuit current will be flowing. So already you have a resistor. Already I told if you have a resistor equal to short circuit, automatically resistance is 0. So the current doesn't flow in this path. So current is not flowing means what is the magnitude of current? I naught is equal to 0. So I am substituting the same I naught equal to 0. So I am writing linking all these sources. So current ISC is equal to plus 10 plus 3 I naught divided by 2. You got the value of ISC. So I am substituting and I am finding R Thevenin VOC by ISC. I got this value. I am substituting all the values in the Thevenin's equivalent circuit. I obtained the value of IL is 2.5. So hope you are able to understand this problem. So I don't want to prolong it more. This is not like by seeing this video you can get this problem. So write down the problem, see the procedure, and try to write down the given problem as it is, and you try to develop the solution and try to get the solution. If you are getting the solution, then you are an successful student. If you get the solution of your own, then automatically your self confidence will increase. So if your self confidence is increased, then you can enjoy the quality of the subject and you can have more clarity on the subject. Hope if the video is useful, just give an like and share with your friends and subscribe to the channel, and please recommend the channel to remaining, which will help us to grow. So hope the video is very much useful. Thanking you, yours Ram.